Welcome to ID the Future. I'm Robert Crowther with Center for Science and Culture. I am in Seattle today in the Discovery Institute, and I'm joined again by our good friend, senior fellow and biologist Michael Denton. Michael is a double threat. He has 2 advanced degrees, one an MD from Bristol University, a PhD from King's College in London. He's most well known probably for his work in the 1980s on evolution, a theory in crisis, and then later Nature's Destiny, and still later Evolution, a theory still in crisis. He's published numerous peer-reviewed journals, most notably in Nature, Journal of Theoretical Biology, as well as many others. He's done a lot of research over a long career, but what we're going to chat about briefly today is his brand new book, Children of Light. It's the 3rd in the Privileged Species series of books. It is about, I guess, in short, amazing properties of light that make human life, actually all life, possible. Is that a good way to put it?
That's a good way to put it. We are, in effect, light eaters, as I described in the book, because, in fact, we get our energy by burning reduced carbon compounds, like sugars, in the body with oxygen. The oxygen unites with the sugar, forms water and CO2, gives off a lot of energy. That's a very, very simplified sort of explanation of what's going on. So, and how do we get oxygen? How do we get reduced carbon compounds? We get it through the process of photosynthesis. And what energizes photosynthesis? Well, it's the light of the sun. And it turns out that, just to digress a little bit, to explain what I'm talking about when I say fitness, the universe has to have extraordinary exact properties so that the light of the sun can actually be used in photosynthesis. Just let me go back to and just talk about fitness for a minute. If you bake a cake, I've never baked a cake, by the way. If you bake a cake, you need eggs, you need butter, you need all sorts of things. You need ingredients, and you need a temperature range, you need a cooker, and things like that. You also need to have a recipe, and you need to have the design, the actual design, approximate design, which you need. You have to mix things in a bowl, so I'm told, things like that. And that's making a cake. But to make the cake, you have to have, as it were, the correct environment, which consists of a set of constituents. Doesn't matter how clever you are at baking a cake, if you don't have those constituents, you can't have a cake. But if you look at a living cell, to make a living cell, even if you're God, you need the periodic table of elements, and you need water, and you need a temperature range. Okay? So whether this first cell arose by God, by Darwinism, or whatever, you need conditions, exacting conditions for it. Now, these conditions are what we talk about when we mean fitness. The fitness in nature for the cell is the conditions necessary to have a cell. The fitness in nature for warm-blooded organisms are the thermal properties of water. Without the thermal properties of water, we wouldn't be sitting having this conversation, because the specific heat of water allows us to maintain a body temperature, a constant body temperature, and the evaporative cooling enables us to cool down when the temperature gets close to body temperature. So you need how, I guess...
That's the wonder of water.
That's right? The wonder of water. That's another book.
That's another book.
And if you want a circulatory system, you need a fluid with a low viscosity to go through the capillaries, and you need a fluid with a good solvent. Can dissolve lots of things. That's the 2 basic requirements, and you get those with water. So in the case of our complex being warm-blooded, etc., we need the properties of water for our circulatory system and the thermal properties for being warm-blooded. And it doesn't matter whether we came about by special creation or by Darwinism, this fitness enabled that in nature from the beginning. So in this book, in The Children of Light, is essentially looking at those, if you want, the ingredients for the cake, or the periodic table of elements for the cell. It looks at the fitness in nature, the conditions in nature which must be there if we are going to use light and for photosynthesis and actually for human vision. So, and it's an absolutely fascinating story, because it turns out that the right light, the light we actually need, occupies an infinitesimally tiny fraction of a vast range of electromagnetic radiations in nature. That is the visual band and the adjacent band, which is infrared or heat. And this tiny band, with great fortuity, is beamed out by the sun. And indeed, all the stars in the cosmos, as I say in the book, is flooded with the light of life. Most stars give out just the light we need for photosynthesis, one infinitesimally tiny region in a vast spectrum, the electromagnetic spectrum. And amazingly, the atmosphere lets through just the same electromagnetic bands in the visual and the infrared. So you feel infrared as heat on the skin, from the sun shines on the skin, and of course you see with visual light. So photosynthesis is lucky, because the sun puts out just the radiation you need, and the atmosphere lets through just the radiation you need.
That's fine-tuning?
It's fine-tuning.
Specifically fine-tuned, yeah.
These are the conditions, like the egg, the bacon, blah, 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 to make the cake. These are the conditions you need in nature if photosynthesis is to thrive on a planetary surface. And what is absolutely amazing about this is that the energy levels of visual light coincides with a region within the electromagnetic spectrum where the wavelengths are just right for forming an image in an eye like the human eye, in an optical device like the human eye. So,
what are the chances, right?
Well, it's like the electromagnetic spectrum is, if you think of a stack of cards stretching from the Earth right away beyond the galaxy of Andromeda, the visual band is like one card in that vast stack of cards. Right? And so, in fact, so the sun gives out that region, the atmosphere lets it through, and that's the exact region you need for photochemistry. And it turns out it's the exact region where the wavelength is right to make an image on the back of the retina. So it's beautiful.
And all of that is in Children of Light.
It's all in
plus more.
Children of Light plus more.
Right.
Yeah. And one of the interesting insights in the book, which I think I can claim as originally my insight, is that when you form an image on the back of the eye, it's because of the wave nature of light. Because light has a wave-like, just like waves on the sea, when they go through an aperture, they diffract and things like that. And so light going into the eye diffracts and refracts and forms an image on the back of the eye. But the light is detected as particles in the photoreceptors. The photoreceptors only see particles of light, so you need the particulate nature of light to detect it, to pull it out, but you need the wave-like form to form the image on the back of the eye. It's beautiful. So you can actually say that, in fact, light's wave and particulate nature is critical for vision. And this is one example of the increasing interest in what you call quantum biology. That, in fact, the quantum weirdness of subatomic matter may be essential for life, and it certainly seems to be essential for vision. So,
is there a book in your future about quantum weirdness?
Not really, no. I'm not a physicist, but it's interesting that Richard Feynman, often voted to be the most brilliant physicist in the 20th century, he says in his book QED, which is, I think, stands for, well, QED is quite easily done, but it also stands for quantum electrodynamics, which is, I'm sure I have that wrong, actually. It's a brilliant book, but in the book he says, nobody knows why nature behaves like this. Nobody understands quantum weirdness. And of course, Feynman also said, he said nature's absurd. And he said that anybody that understands, this is not in the book, he said anybody that understands quantum mechanics doesn't understand it. And this is a top, so I don't understand it, but this is coming from a top physicist. But he says nature is absurd in QED, and we have no idea why it's like that. Well, perhaps we're beginning, he said this 40 years ago, 40 to 50 years ago, and perhaps now we're beginning to understand that quantum weirdness is part of the fabric of reality, and part of the fitness of the cosmos for beings of our biology with the capacity to see the light. Yeah, it's beautiful. It's absolutely beautiful. So we are linked to not only linked to the stars where our atoms are manufactured, and the stars which make the light to see, we're linked to the very fabric of reality, because we couldn't see unless nature had this extraordinary weirdness called quantum weirdness, particle duality, wave particle duality of matter.
Well, I appreciate your explaining that in a way that I could sort of understand.
I can only sort of understand that. Yeah.
And your new book is Children of Light. It's part of the Privileged Species series of books, each of which examines some sort of fitness in nature that we have to have in order for life to exist. Fire in Firemaker was the first book you did. Water and Wonder of Water. Now we have Light and Air and Children of Light.
And hopefully another one, The Purpose of the Atom. That might bring the sequence to a close.
Okay. We'll look for that in the near future. Thank you, Michael Denton, for being with us, and I appreciate it, as always, you're taking time to talk.
Wonderful. Wonderful to talk to you all. Yeah.